Hello, welcome to this video. So in this video, we're going to cover greedy algorithms. Greedy algorithms are the first example of the divide and conquer algorithms that we'll be covering in this week. The other two will be dynamic programming, and we've already covered recursion as well. So let's talk about greedy algorithms more in depth. So what are greedy algorithms? So these are algorithms that simply make the most optimal choice at each step with the hope of achieving the global optimal solution. So once again, the two most important layers to note here is first, we are making the most optimal choice at a particular step. So we don't care about anything else. When we're at step A, we just care about A and we ask ourselves what's the optimal choice there. And we'll continue doing this with the hope that at the end of the day, we'll reach the global optimal solution. Okay, so let's put this into practice to understand it better. So let's take an example of a graph. So this is a graph of places, and you can see we have edges between the different nodes of my graph that represent the distances between these particular points. So let's imagine we want to get from point A to point F, so the points marked in green here. How will my greedy algorithm approach this particular problem? So the first thing we're going to do is we're going to come here to point A, and at point A, we're going to ask ourselves, because we're trying to find the shortest distance between A and F. So at point A, we just ask ourselves which of the two paths, so which of the two edges connected to A is shorter. So once again, we're only focused on A. We don't care about the global solution, just at node A there. And so we go ahead and say that 2 is less than 4, so we choose the route A to B. We go to node B and we realize there's only one path, so there's nothing to compare. So it means our algorithm is going to choose the route B to E, which is the only available one. And then when we get to E as well, we only have one route, so we're only going to choose that route 2 as well. So this is the structure for it, where our algorithm only focuses on the point at hand, chooses that optimal solution, goes to the next step, chooses the optimal solution, goes to the next step, up until it reaches its final destination. So this is how greedy algorithms work. At any given point, you don't care about the global optimal solution or the end solution, you just care about that sort of local optimal solution. Okay, it's one thing to note that while greedy algorithms seem very efficient as to how they solve the problem, which means a very big problem is pretty much condensed to this small subsets of problems that we iteratively keep solving at any given point. Unfortunately, this method does not always lead to the global optimal solution. So this is the biggest problem we have, that the greedy method does not always lead to the global optimal solution. In the previous one, we probably got the global optimal solution. So you can see the distance here, AB, it was 2, 7, and 2. So that's a good example. So this distance there was 11, and I can't see any other distance that was better. So here we could choose 4 plus 3, which is 7, plus 1, 8, and then 2, 10. Actually, even here, we did get the global optimal solution. So our greedy algorithms, we can see from the previous example, does not get the global optimal solution. And this is exactly the same thing. So if we do the greedy approach, we'll still choose, and I'm just adding an extra node here so that we can see how impractical they would be in always finding the global optimal solution. So just like we did previously, at node A, we'll choose the route with a length of 2. At node B, we'll choose the route with a length of 7. At node E, we'll choose the route with a length of E. But the global optimal solution is actually ACF, if you look at it. Because the distance here, unlike the other one, which is 11, the distance here is only 9. So this would be the global optimal solution. Let me just stress this point even more. Even if we were looking for distances between C and F, you can see that the best solution is to just take the route of distance 5 and go directly from C to F. But if we use a greedy algorithm, we'll pretty much just go ahead and say the edge CD is shorter than the edge CF. So we might end up choosing CD, and then we go to DE, and then we go to EF, and that's a less optimal solution because it has a distance of 6 as compared to this distance of 5. So while this is a very easy way to solve a problem, it does not always lead to the global optimal solution. So let's directly contrast the greedy approach or greedy algorithms with what we call the brute force approach. So what is the brute force approach? And I'll probably call this the direct opposite of our greedy approach in that particular front. In the brute force approach, we try all options possible when trying to find that sort of global optimum. And here, we are always guaranteed of reaching the global optimal solution here. So let's take an example. Similar graph we had last time. The only thing is I've added an edge between B and D. So we do have a couple of options. How would a brute force algorithm work? In a brute force algorithm, we have to go ahead and find all the possible paths between A and F. So if you look at all the possible paths between A and F, I can either start from A and go to A, B, E, F. So that's the first path, has a distance of 11. The second path is still going A, B, but instead of going to E, I go to D. So it's going to be A, B, D, and after that, I only have one unique path, which is E, F. So this is actually supposed to be A, B, D, E, F. So my apologies for that. So this gives us a distance of 2 plus 5, 7, plus 1, 8, plus 2, 10. So we just didn't write the E there, but that's a distance of 10. So that's the second path. And then we go ahead and find the third path. Now it's not from B, it's A, C, D, E, F. And you can see that has a distance of 10, or the other path would be A, C, F. And you can see that has a distance of 9. After finding all possible paths and all their distances, and once we know all these particular answers, we go ahead and choose the one with the shortest path there. So in the greedy approach, we're making local optimal choices, so we don't go through all options. While in the brute force approach, we are always looking at all possible options. So the big difference here is here, we have to try all options. The other one, we just focused on the local optimized problem. This one will always guarantee us to get the global optimum solution. The other one does not necessarily guarantee us to get the global optimal solution. So I feel like I've already done this greedy versus brute force approach. So let's look at it first of all. One big difference between the greedy and brute force approach is speed. So the greedy one will be extremely fast and easy to implement because you're always focused on finding the local optima. So at any given node, can I find the optimum solution there without worrying about the grand problem? However, with the brute force method, this is extremely slow because you have to explore all options. And when your options are extremely wide, so let's imagine this is an actual map and you're trying to look at distances between two places in a huge city, then the possible options and corners and junctions you can have to get to that end solution might be just extremely difficult. So this will tend to be a very slow algorithm if we're supposed to explore all possible options at all nodes and make sure we've computed and compared them against each other. So that's a big problem about the brute force algorithm. The second thing is let's look at the likelihood of these algorithms getting the global optimum solution. So we did say while greedy algorithms are extremely fast, they do not guarantee reaching the global optimal solution. And we've seen this in an example while trying to find the shortest path between A and F. Whereas for the brute force one, it will always guarantee reaching the global optimal solution because it has to explore each and every single option available. So it's going to explore all routes available to be able to find what solution is most optimal. But now let's go ahead and ask ourselves, how practical are these two algorithms? For starters, the greedy algorithm is very practical, highly practical at scale. The only caveat here is we really need to increase our chances of getting to the global optimal solution. And we'll talk about this in a future video. How can we improve the efficiency or the likelihood of us getting to a global optimal solution? Whereas if we look at the brute force method, it is impractical at scale. Yes, it guarantees you the answer, but it is impractical at scale. It's only limited to small scale optimizations. Keep in mind when you're talking about scale and we have a network of options, then we have a limitation on computing power and even memory, though we can easily solve for the memory by always only saving the route to the shortest distance at a particular front. But you get the gist that this is extremely impractical given that you have computing limitations. So it might not work with high scale problems. The greedy one can work, but the caveat is, can we increase the chances of getting the global optimum? Okay, so let's ask ourselves the applications of these greedy algorithms. Most of these applications you've already seen, or you're probably going to see, and they're very, very common already. So one example is what we've been covering here, pathfinding algorithms, and we've been doing it in the most layman's way to go for it. However, you guys will be able to see the Dijkstra's pathfinding algorithm in the future. Probably have heard about the traveling salesman problem as well. So these are two pathfinding sort of. So the salesman problem is imagine a salesman traveling all across the United States. what is the shortest path that brings him back to the starting position. Dijkstra's is just trying to find the path between point A and B in a maze, or like in a graph or interconnected graph of edges. So pathfinding algorithms will tend to leverage the greedy approach in trying to find the shortest path. Another one that we're really going to explore in the next video here is going to be hill climbing or gradient descent. For those of you who are familiar with machine learning, gradient descent is not a new concept here. It works the same as hill climbing. How can we find the highest? So we're trying to find the peak of a function. We're trying to find the peak of a series of arrays, and we'll talk about this next. So we're trying to find the highest point of a function, and this could be a very complex function that we have to gradually look for different numbers all across as well. Another type of graph algorithms will be graph search algorithms. You might have heard about depth first search or breadth first search. All of them do employ a greedy approach. One that's extremely applicable in cloud computing here is what we call task scheduling, right? How do we schedule the tasks that are going to be done? So CPU task scheduling. Are we going to schedule them based on priority? Are you going to schedule them based on the ones that take the least time? So regardless of what approach you take in choosing how you schedule tasks in a series of CPUs, you're pretty much using the greedy approach, and the metric you're looking at is what matters to you. Is it a fast in approach? Is it going to be the one that takes the shortest time? Is it going to be a prioritization approach? Still, because you're looking at either priorities or time, you're still taking a greedy approach to prioritize the ones that fulfill that metric that you care about best at that particular front. And the others that you've covered and you've seen so far has been tree-based algorithms. You've probably heard about things such as the minimum spanning tree or the Huffman coding, which was actually a challenge that we issued to you all. So greedy algorithms is just a small sample size of the applications. They're quite widely applied here, so it's worth really taking a note of the greedy approach right now. So let's do a recap of what we've covered today. Greedy algorithms work by making the optimal choice at every step, with the hope of achieving a global optimum. These algorithms are extremely fast and easy to implement. However, they do not always lead to the global optimal solution. We can directly contrast the greedy approach to the brute force approach, which will always find the global optimal solution. However, we did note that the brute force approach is extremely slow. It's impractical at scale because we have to explore all possible options.